A force of 10 Newton drags a mass of 10 kg on a horizontal surface with an acceleration of 0.2 meter per second squared. You have to calculate the coefficient of friction between the mass and the table. Maybe I should just illustrate that using this simple diagram. You have this mass here, so that a force of 10 Newton drags it like this in this direction. Let's assume this direction to the right, and the mass is that is of the block 10 kg. All right, so we are aware that from the question, the surface is not smooth. Frictional force exists between the surface of the mass and the surface of the block. So this type of friction ought to be kinetic frictional force, since the block of mass actually moved forward, with an acceleration a, which is given as minus 2 meters per second squared. So the frictional force will be kinetic, not static. All right, so the resultant force, according to Newton's second law, is mass times acceleration. This resultant force F is given by the difference. I can decide to take the direction to the right positive, the force acting to the left as the kinetic frictional force negative. So that gives me 10 minus frictional force Fk. Of course, that gives you mass times acceleration. That the mass is 10 times acceleration A. Okay, let me just write that as A first of all. So I can use the two sides of the equation, so that 10 minus Fk is equal to 10 times my acceleration 0.2. So that gives me 10 minus my kinetic frictional force equals to, this is 2.0, that is 10 times 0.2. So that this eventually becomes 10 minus 2, that gives me 8 Newton. Now the 8 Newton gives me the kinetic frictional force, but I must to find the coefficient of this frictional force, okay? And then frictional force Fk is equal to mu, which is the coefficient of friction, times normal force N. And my normal force is equal to the weight of the block, which is mg. Okay, so my normal force is equal to 10, which is mass of the block. I use my g as 10. The question says take g as 10. That gives my normal force as 100 Newton. Alright, so that this is my value for frictional force Fk, that is the kinetic frictional force. So that I have Fk now equals to mu k times normal force. That's, I've got that already. So that gives me 8.0, which is my this frictional force equals mu k times 100. That is this, therefore finally becomes 8 over 100. That is 0.08. Recall that coefficient of static friction or kinetic friction, they have no unit, okay?